Hello everyone. In the previous video, we have learned about angle between the two lines, intercept form of a line, and slope intercept form. In this video, we will be learning about normal form of a line, which is very important for class 11. So, before going to the normal form, as I already mentioned in the previous video, normal means it's a line perpendicular to the other line which is passing through origin. Let me take, not necessarily it is passing through origin, normal means it's generally a perpendicular, two lines if they are perpendicular, one is normal to other. Now, let us assume here for the equation of line, there is a line here. I always take the line to be slanted. The reason is, if it is horizontal, it's parallel to x axis. If it is vertical, it's parallel to y axis. If it is slanted, it is neither horizontal nor vertical, it is making some angle theta. So, here when I am trying to derive the normal form, I have taken a arbitrary line in a coordinate plane, xy plane, and let me try to draw a perpendicular from origin and meeting this line at a point P. So, this perpendicular, okay, let me take this perpendicular distance as P. So, you can name this as another point, let me take it as A, so in order to avoid confusion. So, I took a perpendicular from origin to the line. So, I am finding the normal form of a line, means your line here is normal to the line which is perpendicular from origin. So, let me take this perpendicular line is making some angle theta with a positive direction of x axis. Then here one small logic here, when I have theta angle, means it shows the direction or it is slanted one, and we have a perpendicular distance. What is this P? As I told earlier, this P is perpendicular distance from where? From origin to straight line. Okay. So, B is a perpendicular distance, I have a perpendicular distance and I have an angle. How can we get the coordinate of A? How can we get the coordinate of A? For that, let me take an imaginary perpendicular here. Let me assume that this perpendicular meet the x axis at a point B. So, you have a theta, you have a P, let me take this is a right angle triangle. So, you have a hypotenuse, you have an angle, we need a base and perpendicular. For that, we will apply cos theta, this is base upon hypotenuse, and sin theta, which is a perpendicular upon hypotenuse. So, that means you will get the point A as here we have P cos theta and here we have P sin theta. So, the point A has P cos theta comma P sin theta. These are the points. It's okay. It is a point A which is on the line. Now, I have this point. One point is there for the line equation. I would like to derive this line equation. So, what I need extra when we have a point, we need two conditions for the equation of line. So, what is the another condition, and we can find, as we have learned, angle between the lines. Now, this OA and the line is making how much angle? OA and line are perpendicular, means 90 degree it is making. If suppose OA slope is how much here? Tan theta. And the line slope is, I don't know the line slope, let me take it is M. Can we find the line slope? Yes. We have angle between the lines in the previous video. If you want, you can go through the previous video, the angle between the lines. If they are perpendicular, then we have 1 plus M1 M2 equal to 0. Or you can also say M1 M2, the product of slopes is equal to -1. But what is here M1? Here 1 plus M1 is tan theta and m2 is a small m, the second one is equal to 0. We would like to find the m value. So, the m value will become minus 1 upon tan theta. So, this is the slope of the required line. Now, I have a slope here and I have a point here. So, when we have both the slope and point, we can write the equation of line. How to write the equation of line? Y minus y1 is equal to a slope into x minus x1. I am taking the point slope form. So, point is here y1, which is y minus p sin theta is equal to, the slope is what? Negative is 1 by tan will become cot, and I can write that as cos upon sin into x minus, what is x1 here? P cos theta. Now, let us take a small cross multiplication thing. So, we have y sin theta is minus p times of sin into sin is sin square theta is equal to minus x cos theta minus of minus plus p times of cos square theta. Now, in the line equation, generally x and y terms will be in one side and the constant at the side. So, this x cos theta I will take to the left side. So, I will get x cos theta plus y sin theta is equal to, your constants are what? P cos square and minus p sin square. Let me take this minus p square sin square other side and take p common. We get cos square plus sin square, and we know from class 10 this is the identity in cos and sin. So, finally, what we get, the equation of line is x cos theta plus y sin theta is equal to p. So, this is a normal form of equation of line, very important for class 11. Now, at the end we will go with the last equation of line, which is symmetric form. In this is a very simple one. Symmetric form will have one point here x1 y1, and another one is your slope, which is denoted generally as a tan theta. That means we have a point and the tan theta. In the symmetric form, you will have y minus y1, m is your tan theta into x minus x1. So, when we convert this tan theta as a sine upon cos, the y minus y1 upon is equal to sine theta by cos theta into x minus x1. Now, let me take the sine theta to the left side. So, we will get here difference of x upon cos theta and difference of y, this is y minus y1 by sine theta. So, this is symmetric form of a line. Difference of x upon cos theta, difference of y upon sine theta is called symmetric form of a line. So, we have how many forms of a line? So, in the first video we discussed about the general form of a line in class 10, then we have discussed horizontal line, vertical line, slanted line. After that, we have gone for the equation of line passing through origin and having slope. The second is equation of line having 2 points, then we have point and slope, and we have intercept form both x and y, then we have intercept and slope. There are total 5 are done, and this sixth one which we have discussed now is a normal form of a line and then symmetric form of a line. So, normal form and the symmetric form are added in class 11. So, these both are very important. Normal form of a line is x cos theta plus y sin theta is equal to p. Your p is perpendicular distance from origin to the line, and theta is the angle made by this normal line with a positive x direction. Thank you.